You need to be in the door by 6:30, and then you can work till 8:15. Okay, so what we're going to do is, so you can keep your homework to study, and we'll turn it in Friday, okay? Turn your homework in Friday, and we'll spend today talking about questions from the homework. And what I choose to talk about is very intentional to help you the most possible with the exam, this material in the exam, okay? So don't just take this time to kind of just copy down what I talk about so you can turn in the homework and get points on Friday. So think of it as part of your studying for the exam, okay? So let's take some suggestions. I definitely want to do what is it? The diver problem? Yeah. 26 we'll do. And it's 35, is that the coffee shop? Okay, so we'll do those two. And then we'll leave the rest to see if we can find some consensus from you all. So suggestions from the remaining problems that we're due today. You want to talk about? People are saying 21, okay? 35 we'll talk about. 26 and 35 we're going to do. What's that? 23? Other suggestions? Yeah. 26? Yeah, we're going to do 26 and 35 for sure. Other suggestions? Yeah.
You do 29.
29? Last chance to nominate a problem. Okay, yeah. 25? We're going to do 35. So 26 and 35 we're going to do. Any other suggestions? Okay, so that leaves, that's 5 problems. We have time for that, so let's do that. So 21. So in 21, what form are we given here of the polynomials? Remember we talked about two kinds of forms of polynomials. Sorry. Yeah, standard or expanded form. And what was the other? Factored, right? So and so which of these two are they giving us in 21? This is the expanded form, right? It's not factored out. In order to find zeros, what form is most helpful for finding zeros? Factored form. So, conclusion? We need to find factored form. And so, it looks like all these can be factored. So this is back in your algebra days. We're factoring these things out. So let's like this first one. So we got to multiply to negative 12 and add to 4. So x, I guess, plus 6 minus 2. Is that right? Does that do it? Okay, so one like this. So exact zeros. So what are the exact zeros for f? Negative 6 and 2. This factor here gives a negative 6. Not collecting today. Not till Friday. So this factor gives a root of negative 6. This factor gives a root of 2. All right, so let's do this one here. So this one is a cubic, but what can we do first? We'll do x first, and then what's left, we'll have x squared minus 10x plus 21. So we need product of 21 summing up to 10. Okay, so what are the roots? 0, 7, and 3. 0, 7, and 3. Okay, what can we factor out of this one? We can get an x squared out. So you're going to take all the x's that you can out first, and we'd be left with negative x squared plus 1, which is harder to see. If we pulled out negative x squared, we'd have x squared minus 1, which might be a little more familiar. What about x squared minus 1? Yeah, x plus 1, x minus 1. So your roots would be 0, 1, and negative 1. Any more questions on 21? What's that? F. So it's just kind of like a, it's like a puzzle. You just got to figure out how do you do this. You're going to have 2x and x, and you have minus 3. So you can do plus 1 and minus 3, or plus 3 and minus 1, and you got to figure out which one goes where so that you get minus 5x. So you just try until you make it work, right? So I'll leave it to you. I think you can figure it out. So you got to get it so that if you were to multiply this thing out, it would be this one here, 2x squared minus 5x minus 3. Other questions on 21? Okay, what would you do first? Who asked the question? What would you do first? Yeah, and what would you be left with? You could actually pull out 2x, and what would you have? X. Negative 5, I agree. And? So easy it's hard, right? No. So roots are values of x that make the function 0. Values of x that will make the function 0. 0. What about 2? Does 2 make it 0? No, so it wouldn't be 2. So again, just remember what a root is. It's values of x that make the function the output 0. You're looking for those values of x that would output 0. Okay, what's next? 23. Okay, finding the leading term and then end behavior. So leading term, what do we look for to find the leading term? We're going to look for the highest exponent. And it's not necessarily the first one. If it's often they're written in descending order, but it's not always the first one. So what is our leading term here? Negative 4x to the 6th. What's our leading term here? 9x to the 9th. Okay? how can we find the leading term for this without multiplying the whole thing out? So that's what, so we'd have to get expanded form and then look for the leading term. But if we just want the leading term, is there a shortcut? So we talked about this in previous days. You're going to go to each factor and get the highest contribution from each. So that first one gives us x. What do we get from this? X squared. It's the from this 2x, and from this. So as we're doing all the combinations of multiplying one from each, this one will give us the highest power. What is it? 2x to the 5th. Same thing here. We'll have -4. We'll get what from this? X, and what from this? X squared. So it will be -4. Okay, so let's do end behavior for just one of these. I don't understand it. There's a test tomorrow. Why would you leave class the day before the test? Right, exactly. Okay, which one do you want to do for end behavior? C. 2x to the 5th. So end behavior means if you go way out to the right end, that's very large x values, positive x values, way out to the right. What will x to the 5th be? Positive, right? Really big positive, and then if we multiply by 2, still really big positive. So as x goes, if we go way out to the right on the graph, the graph will go up, function will go up. Okay. As we go way out to the left on the graph, very large negative values. What about x to the 5th? Negative or positive? Negative. Multiply it by positive 2. Still negative. So as you go way out to the left, you go down. You'll go down. So at the ends, this graph will look like this and like this. As you go way out to the right, did I get that wrong? I got that wrong. What did I do here? No, I had this right. Yeah. So as you go way out to the right, it's going to go up. As you go way out to the left, it's going to go down. Yeah.
Is the end behavior two different lines, or is it?
There's the right end and there's the left end. The right end is going out to where x goes to positive infinity, and then we're asking up or down. And then the left end going out to negative infinity, then we ask the same question, up or down.
So there should be two answers for two parts.
There's the right end and the left end. Yeah, right end and the left end. Other questions? Sure. So I just discourage you from kind of memorizing tricks like that. Just analyze each one. So when x is very large positive, ask yourself, what will that do? And then multiplying by 2. So I just recommend just analyze each one every time instead of trying to memorize. Because if you, this is what happens. If you kind of memorize it wrong or you have a wrong conception, then you can't get it. But if you can reason it out, you can always get it. So I just recommend, go through this process that we've been going through. Other questions? What's that? Sure, which one? D, -4x cubed. Okay, so as x goes to positive infinity, meaning the right end, so first look at x cubed. Will that be positive or negative? Positive, and then multiply by -4. Negative, so y will go to negative infinity, or down. So at the right end, the function will go down. Okay, then at the left end, negative infinity, So now we're saying very large negative numbers. What will x cubed do? It will be negative, but then we'll multiply it by -4. So we're saying at the left end, the function will go up. At the way out at the left, the function will head up. Did that help? Cool. Next one. 26. Okay, so when you're graphing polynomials, like for instance, if you wanted to practice problems like this, you analyze everything, right? You get the middle behavior, you get the roots, multiplicities, end behavior, and then you try to sketch the graph. In that case, you don't want to use your graphing calculator unless to check at the end, okay? So the problems like this, where you're just trying to sketch a polynomial, I encourage you to try to do it without your calculator and then check at the end. But a problem like this, where it's giving you an application, and then it's asking you all kinds of analysis questions about what's happening, comparing the two quantities, here's the right time to use the graphing calculator. So I highly recommend this one. You just do it completely by the graphing calculator. So if you've got one, you should have one for the exam. But get it out now, and let's work through it together using the graphing calculator. So it's h of t, so height as a function of time, and there's the rule. But in your graphing calculator, you're going to use y and x. So in your y equals screen, it'll be something like this. Y equals -4.9 x squared plus 8x plus 10. So now the next thing is you're going to get something that might not be the kind of screen that you want to see this well. So what is imperative in these problems is that you know exactly what quantity you have on the x-axis and on the y-axis, and knowing what those quantities are will help you to set the ranges so you get the best window to see this thing. Okay, so let's review that. So what is x in this context? So never, in an application problem that you're graphing something, never do anything until you know confidently what the quantity on the x-axis is and what the quantity on the y-axis is. What's our x-axis quantity here?
Seconds.
Okay, that's the unit. What's the quantity? Remember our first week of class? Defining quantities?
What number is
26. I think. Is it 26? We're doing the diver.
it? You mean seconds since jumping off of the dive?
That's right. Time elapsed since jumping. And that's in seconds, right? So seconds is important. Okay, what is the y quantity?
Height.
The height, what height? The height of the diver above the water. So, we think about time elapsed since jumping off the diving board, and we think about, okay, what's a reasonable span of time that would make sense? 0 to 1,000 seconds? 0 to 100 seconds? -10 to 10 seconds? So what's our minimum? What should our minimum be? 0. What's a reasonable maximum time, just to make sure we see everything? So you might have said 5 or 8 or 10 or something like that, okay? So that would, you go into your window and set your x min at 0 and your y min at, you could do 5 just to be sure, or you can see that it's less than 3. So anything 3 or anywhere from 3 to 8 would be good. Okay, height of the diver. So what's the initial height of the diver? 10 meters. So should we look up to 50 meters? 40? So how high should we look? If there, what's that? Yeah, so maybe the diver will get up a couple meters from the initial jump, but not 10 or 30 meters. So if it's starting at 10 meters, then you could try a Y max of 15 or 20, something like that. And then when you get that, you should end up with a graph like this. So this is a decent view of this. Okay, maybe. Okay. Okay. All right. So then it asks, how long will it take? So let's look at some key points on this graph. So there's a key point here. What ordered pair is that? 10, 0. 0, 10. Which is it? 0, 10. And exactly what does that ordered pair mean? So what's that? At time equals 0, he's 10 feet above the water. Agree? 10 meters. Okay, 10 meters. Exactly. So every point on this graph, here's the point, 1.55. And I can't see, 10.63. So you should be confident. So every point on this graph has meaning, and you should be confident exactly what the meaning of every point is. So if I gave you this point 1.55, 10.63, someone in the back, tell me what that means. This point right here, what does that signify or represent in this situation? After 1.55 seconds, the diver is 10.63 meters above the water. Well said. Okay? What about this? So we got a key point down here. What's that? Okay, is it the X or Y value when he hits the water? The Y value is 0. So we can find that point on your calculator if you go second calc, which is second trace. Then there's the 0. What number is 0 option? Number 2. So it'll ask you for the left bound, which means you move the cursor somewhere to the left of this point and hit enter, and then move the cursor somewhere to the right and hit enter, and then it says guess. It's asking you for a guess. Put the cursor as close as you can to that and hit enter, and it'll give you the 0. And I get 2.46. Anyone having difficulty getting that with your calculator? We're good? Everyone able to do it? So the first question they ask is, how long does it take for the diver from the dive to hit the water? How long does it take for the diver? 2.46 seconds. Okay, so the time from the jump to hitting the water would be this delta t right here. From here to here, that would be a change in time, which would be the time it takes to hit the water from there to there. Okay, what about the time it takes from the jump to reaching the maximum height? From the time it takes from the jump to reaching the maximum height. Okay, so the maximum height is the highest y value. Again, do second calc and then maximum. Again, it's going to ask you to go to the left of the point, hit enter, It's going to ask you to go right of the point, hit enter. It's going to ask you for a guess. So put the cursor as close to the top as you can, hit enter, and it should give it to you. So I get 0.816 and 15.27.
I got 13.
Yeah, it's underneath my Y there. I couldn't see. Yeah, you're right. 13 point, we'll call it 3. How about that? So we had to be able to interpret that point. So those numbers, 0.816, 13.3. Tell your partner, person next to you, exactly what does that point mean. All right, really important. Go. What does that point mean? Okay, what's the 0.816? What seconds? How many seconds? Until what? That's right. It's the number of seconds or the time from the jump to reach the highest point. And what's 13.3? It's that height in meters above the water at that time, at that highest point she reaches. Okay, so someone was analyzing this problem, suppose, and they said, oh, this is the diver jumping off the board and cruising through the air into the water. Is it true? This is the path of the diver in the air. Yes or no?
Yes.
Path of the diver in there. Some saying yes, some saying no. You said no back there. Why not? Could she be jumping straight up and down?
No, because she goes into the water.
What's this quantity? This is time. This is not horizontal distance. If it were horizontal distance and that were height, then yes, this would be her path. This is time. Could she be jumping straight up and straight down? According to this, could she be jumping straight up and straight down? Yes. Absolutely. Yes. Yes. Because this is the time quantity. This is time going by, and we're monitoring her height as time goes by. So, not the path of the diver. Okay. All right. So, I asked a question, how long does it take for her to reach the highest point? 0.816 seconds it would take to reach the highest point. How long does it take from the highest point to hitting the water? How much time from the highest point to reach the water? Are we going to look at x values or y values? X values. And so how are we going to calculate that? 2.46 minus? What do you get? So what is that? That's the time it takes from? The max to? So that's this delta t right here. That's that delta t right there. How the time it would take from the highest point to hitting the water. Okay? What is the average rate of change over that time period? Do you know how to, so over that time period, from the highest point to hitting the water, what would the average rate of change be? How would you calculate that? Okay, someone said delta y over delta t, or change in distance over change in time. Agree? Change in height over the change in time. So what change in height? Well, we know the change in time. What's the change in time? 1.64. What's the change in height for this change in time? 13.3. Agree? A couple people are saying it should be negative. Negative or positive? Okay, so final minus initial, or is that change in height, is it a positive 13.3 or a negative 13.3? It's negative. All right. They are right. Because we start up here and we go from 13.3 to 0. That's a negative change. That's a negative change. Let's get that value. What is it? Negative 8 point. So we'll say negative 8.1. What's the units? It'll be the height unit over the time unit, right? Okay. So this is the speed the diver dropped at. Is that right? So from the highest point to hitting the water, the diver went this speed. Is it correct?
That's incorrect.
That's incorrect. So you shook your head. Why? Why not? Okay, this is the average rate. Is the diver's rate constant or changing? Changing. Okay, and so we can look at that by looking at what? Equal increments. What happens to changes in height for equal changes in time? More negative. So these are negative changes becoming more negative. So are those changes increasing or decreasing? This is the confusing thing. So there's one question. Is that rate of change increasing or decreasing? Decreasing. Why? Because those changes are becoming more negative. Is the diver speeding up? Yes, that's the confusing thing. The diver is speeding up. But because those changes are negative, or the rate of change is negative, we have to be consistent, we call that a decreasing rate of change, because the rate of change is becoming more negative. Okay, so we worked hard on this a week or a week and a half ago. Okay, so don't forget. When the changes are becoming more negative, that's a decreasing rate of change. Okay, so the rate of change of the diver is decreasing, but this is what kind of rate of change? This is a constant rate of change. So how do we make sense of what is this constant rate of change relative to the diver whose rate of change is changing? So how do we make sense of this average rate, which is a constant rate? Remember? What's that? Okay, yeah. So if another diver were to start at the same height and fall at this constant speed, what would happen? They would hit the water at the same time. So it's like another diver who's falling at a constant speed would cover the same height in the same amount of time. And what would that graph look like? Yeah, so the graph of that second diver corresponding to this constant rate would be like a straight line. Let's see how I do. I pushed the button is what I did.
Why are we going from 13.3 feet and not starting at 10 feet for time zero?
Up 13.3 and then start so we think about a guy jumping off a diving board, he's first going to jump up and down. He's not just falling off the diving board, he's actually.
Oh, I know, but the average rate of change from 0, you should get a less steep line from time of 0. We're starting at time of 1.
It's just where I decided to start. I just said, once I asked this question about the time it took from the high point to the water, then I just ran with that. So, Yeah, so it's just the question I asked. Yeah, okay. So this represents like a phantom diver, okay? Like another diver that doesn't really exist, okay? But if it did, he would fall at a constant rate, starting at the same height, and over that amount of time would fall the same distance as our actual diver. So they'd hit the water at the same time. So that's the meaning of average rate of change. Okay, and then we'll do that later. So you were to find some other average rates. I think every half second starting at 0.5? Every half second starting at 0? So you're finding constant rates between every half second of time, which would represent these straight lines. Those are supposed to be straight. And so those average rates tell the same story. So the average rate is doing what every half second? Increasing or decreasing?
Well, it slowly increases to...
The average rate. So the average rate is okay, so the height in the first part here, what's the height doing? Increasing. But the rate is decreasing, okay? The rate is decreasing, and you'll see that in the numbers. When you find that first average rate of change, that'll be higher than the next one. And then the average rates will turn to negative. Are these increasing or decreasing rates of change? 1, 2, 3. Increasing rates or decreasing rates? Decreasing, because they're becoming more negative. So the whole time the rate of change is decreasing, and that's why the graph has what shape? Concave down. Concave down corresponds to the rate of change decreasing. That's either getting less positive or more negative. So less positive rate or more negative rate means decreasing rate of change, and that's why we get that curve, that concave down shape. Okay, so lots of ideas we're talking about all at once here. So anybody have a question? Yeah.
Just for clarification, I understand when it's coming down, the height is decreasing.
The height is decreasing, that's right.
Decreasing rate because it keeps getting more and more negative.
More negative.
But what if it slows down that way? What would you call that? Because
So then the changes would be becoming less negative, right?
Mhm. But you wouldn't call that. Would you call it? It's
So the changes here are becoming the biggest negative's there, then a smaller negative, less and less negative each time. So there the rate is increasing or decreasing if it's becoming less negative. Increasing.
okay.
Increasing rate of change. Yes, sir? What's negative? This one right here? No, because they're not positive in the first place. So more positive would be like this. So their negative changes becoming less negative. If you'd continued, then eventually you'd hit positive and they'd become more positive. So all through there, your rate of change is increasing. Okay, good questions. Other questions? Okay, so does that... I kind of went off and talked about other things which were important, but did I hit everything in the question itself? Okay, there's one more thing. Right before the last exam, we talked about what's called the difference quotient. So I want to just briefly go over that. It's really important. So if I start here at some time, and I look at some change in time, And often that change in time we'll call h. What's the average rate of change starting at time t over an interval of h? Can you come up with the average rate of change over this interval? So it'd be the represented by the slope of the straight line between those 2 points. Just pretend it ends there. I'll try again. So while I'm redrawing it, can you write the average rate of change between these 2 points, starting at time t and ending h seconds later? Can you write the average rate of change? See if you can do that. While I try to draw a straight line here. Not bad. So the slope equals the average rate of change. Can you write, so this is t, this is our h of t function, the height as a function of time. How many people think they can do it? Just curious. A third, okay? So what do we need? What's the general formula to get this average rate of change? Delta h over, okay, so what's the change in height? What's the height here at time t? No, at any time t. No, what's the height here? H of t, right? No matter what time we pick, we can represent the corresponding height as h of t. What's the height here? Oh, sorry. Yeah, this is a little confusing. So we'll just stick with delta t. Okay, so what is the height here? H of? What is this time right here? T plus delta t, right? It's delta t later after t. So the height there is, so what's the change in height? What's the change in height? H of, that's right. So that numerator, what does it represent? Just the numerator. The change in the output over what interval? Over an interval of delta t starting at t. You see that? So that's the change in height over an interval of delta t starting at t. And then in the bottom, just delta t. So this calculates the average rate of change over an interval delta t starting at any time t. And we call this not quite the derivative, the difference quotient, because it's a quotient made up of differences, the difference in height and the difference in time. And what does the difference quotient give? It gives the average rate of change over that time interval or over that change in input. I'm starting at that value. So if we had y as a function of x, then that difference quotient, we could use delta x. There's where we often use h. And you might see the difference quotient like this. F of x plus h, final value of the function, minus initial value of the function, all over h. So change in y over change in x. Change in y over change in x, the difference quotient. So this is a really important kind of building block in calculus. So we're not really taking it to the next step yet to see why we do this, but it's just a really important thing. And we know, we've talked all about average rate of change. So this is kind of like it's like an average rate of change function. We can allow that starting value to change, and we can allow the time interval to change, or the change in input. So it's like an average rate function is what that difference quotient is. Okay, before we go on, any questions about that?
Why would it not be h of t minus h t plus l?
Because the change will always, so if I was 6 feet tall, and then the next day I was 6'5", how would you get my change in height? What would you do? Subtract which from which one first? You would do this first, right? You do that minus that. You do the final minus the initial. So that's why we do this one first, because that's the final height minus the initial height. Make sense? Yeah. Okay? Not based on a true story. Okay? It took longer than a day. All right. So, other questions? All right. Let me give you one practice problem. Can I erase this? That's important stuff. All right, let me give you one practice problem here. Find a formula for this polynomial. No graph. So this is an example where you don't want to use a graphing calculator. See if you can do it. So find a formula for this polynomial. If you need to work, there we go. So one thing you can do to start is identify the roots, find the corresponding factors, and the multiplicity. Yep. Well, either is fine, but that's going to make the most sense here. How many roots we got? First one. So what's the factor associated with the root of -2? X plus 2. So we can just build this thing one factor at a time. X. Okay, multiplicity at -2. Multiplicity of 1. Multiplicity at 0. 3. So because it has the behavior of a cubic there, right? It goes through, but it kind of hovers. All right. What about x minus 3? 1. All right. So now we can get just a starting point for building this function. It'll be y equals x plus 2 to the 1 times x to the third times x minus 3 to the first. Is there only one function that has all those qualities? No, there are many, because we could put any real number here. We could put any real number out there, and everything we've talked about so far remains intact. Okay? So we need to figure out what that number is. How are we going to do it?
End behavior.
No, the end behavior would only get us whether it's positive or negative. We got to get that exact value. Yeah, this point. So that this point locks in a specific value of a that only this polynomial has. Okay? So what does that point say? It says that when, what's that? When x is negative 1, y has to be negative 1. So therefore, if we were to put negative 1 into this function, we would need the value of a such that y would be negative 1. So this is 1 times negative 1 times negative 4, which is 4a. So 4a equals negative 1. Therefore, negative 1/4. So that's the particular value of a that we need to have those roots with those multiplicities and have it go through the point negative 1, 1. Okay, did you catch it? So I had to go fast because we're, yeah.
On the test, will you always give us a point like that?
In order to know, you'd have to know some point. So maybe the y-intercept or something like that. Okay? Let's see if it's right. Is that what we got? Okay, so use the Tutor Center. Web work is open. Those are great problems. Get your questions answered. So find me or go to the Tutor Center. Test is tomorrow. 10:30 to 6:30. You have to be in there before 6:30. And work till 8:15.
So would you just recommend